Introduction. A solar oven is a structure that uses solar energy to generate high temperatures, which can be used for various purposes such as cooking, food industry, or research. These ovens work by using mirrors to concentrate sunlight into a small enclosed area where food is placed. Solar ovens can be a useful tool to combat deforestation in developing countries. In many rural communities, firewood is used for cooking, which can lead to excessive tree cutting and soil degradation. Additionally, the use of wood burning in stoves has been shown to harm human health. Firewood smoke contains harmful chemicals like benzene, formaldehyde, and polycyclic aromatic hydrocarbons, which are carcinogenic. According to the World Health Organization, firewood smoke in enclosed space accounts for 35% of lung cancer cases in Mexico. Furthermore, exposure to firewood smoke can cause other respiratory and cardiovascular disease. By offering a clean, sustainable energy source, solar ovens help reduce firewood use and preserve natural resources. Beyond environmental benefit, they can also positively impact public health. Solar ovens with aluminum work by coating the inner side of the lid with aluminum or aluminated plastic, which acts as a mirror and reflects sunlight into the oven's interior. In solar cookers, concave mirrors are used because they concentrate sunlight at a single focal point, where a large amount of thermal energy accumulates. By reflecting all solar radiation to this point, a height conversation is achieved, sufficient for cooking food. This project will focus on replicating the functionality of solar ovens using accessible materials, like mirrors and aluminum, and determining their effectiveness in raising water temperature. Determine the efficiency of aluminum and mirrors as reflector and thermal energy concentrators in solar ovens. Specific objectives: 1. Build aluminum solar oven. 2. Achieve the boiling point with water. And 3. Complete the project on time and within scope.
Materials for solar oven with mirrors. Mirrors or mirror sheets, 4 or more, depending on the number of reflectors desired. Aluminum foil, as an alternative to mirrors for additional reflective surfaces. Transparent plastic wrap, to cover the top and trap heat with a low installing in. Black poster board or black paint, to cover the cooking area and absorb heat. Adhesive tape, strong glue, or silicone, to secure parts of the oven. Scissors or box cutter, to cut the box and other materials. Measure and tape or roller, to measure the mirrors and box. Newspaper or insulating material, to insulate the oven. Thermometer, optional, to measure internal temperature. Procedure for solar oven with mirrors. 1. Prepare the main box. Choose a large cardboard box of the oven structure. Put a window on the top of the box, the size of the cooking area, even the entire top or the central section. 2. Line the interior. Cover the interior with aluminum foil, especially the bottom and sides, to reflect light to the cooking center. Cover the base with black poster board or paint in the black, to absorb heat effectively. 3. Install mirrors or reflectors. Cut the box flat, the size of upward, and attach mirror or reflective sheets to them. Use glue or hinges to secure the mirrors, allowing adjustment of the angle. 4. Adjust mirror angles. Position the mirrors to reflect sunlight directly into the cooking area inside the box. 5. Insulate the oven. Optionally, place a smaller box inside, the larger one for better insulation. Fill the gap between the boxes with newspaper or insulation material. 6. Print a transparent lid. Put a piece of transparent plastic wrap to cover the top opening. Ensure it's still sealed to prevent weight loss with allowing soiling in. 7. Test the solar oven. Place the solar oven in direct sunlight and use the mirrors to maximize light reflection into the interior. Add food to the cooking area and monitor the temperature using a thermometer if available. 8. Cooking. Allow the solar oven to preheat before placing food inside. Check periodically to ensure food cooks evenly.
Aluminum oven materials, cardboard pieces, PVC tube, screws, contact paper, masking tape, varnish, black paint, poster board, tire. Steps. Number 1. Draw the parabolic temple on poster board using 15 by 15 cm square, dividing it in half. Number 2. From the starting line, draw 1 cm space line up to 25 cm. Number 3. Take a long piece of cardboard and make 2 perforations 50 cm apart. Number 4. Use a nail to fix the center of the circle and draw the arc from corner to corner of the square. Number 5. Cut out the parabolas. Number 6. Repeat the previous steps through one more time. Number 7. Put the pieces together to create 16 total pieces. Number 8. On other poster board, draw up 40 by 40 cm square. Number 9. Draw a circle with an 11 cm radius. Number 10. Draw another circle with a 20 cm radius on the same poster board. 11. Divide both circle into 16 equal sections. 12. Mark a 6 mm thickness along each line. 13. Attach contact paper to the cardboard. 14. Place the drawing from steps 9 and 10 onto the cardboard and cut out the shapes. 15. Perforate the assembly piece so that the PVC tube can pass through. 16. On each parabolic pieces, cut a perpendicular notch on the straight side, 10 cm from the parabola, 10 cm long, and 6 mm thick. 17. Assemble the parabolic section onto the assembly disc. 18. Create 16 spacers, each 18.9 cm wide and 5 cm tall. 19. Attach the spacers with masking tape and secure them with glue. 20. Apply glue around the PVC tube and insert it into the assembly disc. 21. Cut 2 10 cm radius circles from cardboard. 22. Attach a 75 per 21 cm pieces of poster board to the edge of 2 continuous parabolic sections using tape. 23. Outline the outer contour of the poster board with marker. 24. Cut out the external envelope pieces. 25. Attach 50 per 21 cm piece of poster board to the edge of 2 continuous parabolic sections using tape. 26. Outline the inner contour of the poster board with marker. 27. Cut out 16 pieces for the inner envelope using the template. 28. Attach edge outer envelope pieces onto the edge of the parabolic section, intercalating them. 29. Attach the remaining edge pieces to fill the caps. 30. Place a finished disc at the center of the exterior. 31. Apply tape between the other envelope joints, slightly compressing the edges. 32. Attach 8 inner envelope pieces to the edges of the parabolic sections. 33. Attach the remaining edge pieces once the first set has dried. 34. Place a finished disc at the center. 35. Cover the outer envelope pieces with aluminum foil. 36. Perforate a circle near the cardboard spacers. 37. Apply tape to the edges of the circle. 38. Attach a small flat surface to the edges of the parabolic mirror with a nail or screws perpendicular to it and parallel to the mirror's axis.
Summary of finding. The study evaluated the performance of 2 solar ovens, one made of aluminum and the other of mirrors, while the mirror-based oven maintained its temperature for a longer period, 35 minutes. Neither oven met practical expectation. Attempts to cook and failed as the oven did not exceed 90 degrees, far below the 70-80 degrees needed. The temperature achieved were insufficient for boiling water or cooking food, limiting the real-world applicability. The results highlight that material choice affects thermal performance. The aluminum oven lost heat significantly, whereas the mirror oven retained heat better but still failed to reach functional temperatures. Recommendations for future studies. Optimize the sinks. Explore improved the sinks to maximize solar energy utilization.